Question 25. Metal X acts as a sacrificial metal to prevent iron from corroding. Corroding is wearing away, okay? Metal X does not act as a sacrificial metal to prevent aluminium from corroding. What is X? That means that metal is less reactive compared to X, because we always have galvanization of iron, where they put zinc on top of iron. So you have a layer here, okay? So if there is a scratch on that iron sheet and then exposes iron, this is iron and this is zinc. So because zinc is more reactive than iron, it is going to react with the oxygen first, and then it forms the zinc oxide, which is going to cover here. Then iron will not rust. So that's why those iron sheets which are galvanized are always expensive compared to the ones that are not, okay, because of this layer of zinc that is put on them. Now, what we are having here, we are talking about aluminium, to prevent aluminium. So metals that are more reactive than aluminium, we see magnesium is higher than, we have magnesium, we have zinc. These ones are way below. The copper and silver are way below aluminium in electrochemical series. So metal X does not act as a sacrificial metal to prevent aluminium from corroding, okay? So magnesium is actually higher than aluminium in electrochemical series, but zinc is below aluminium in electrochemical series. So the one that is below aluminium cannot act as a sacrificial protection. It has to be much more reactive compared to aluminium. So our answer has to be D here. You see, they even said metal X acts as a sacrificial metal to prevent iron from corroding. The one we know there is zinc, like I've just explained before. Question 26. Which equation represents the reduction of a compound found in hematite in the blast furnace? In the blast furnace, remember at first we have coke reacting with oxygen to give us carbon dioxide. Then as this carbon dioxide rises, it finds more coke or carbon and it forms carbon monoxide. Now that carbon monoxide reacts with the heated iron 2 oxide, iron 3 oxide, to give us iron and carbon dioxide, okay? To balance this, I'll put a 2 here for iron, and then if this is 3, and let's say we put here 3, that means oxygen becomes 6, then carbon is 3, so we shall also put a 3 here, and then 3 times 2, that is 6 for oxygen. So this one here, that equation is for the reduction of iron 2 to give us iron, okay? So the answer has to be D here.